There are more than 1.8 billion Google accounts in this world. Yet, have you ever wondered that whenever you try to create a new account, when you type in your cool username, Google immediately tells you if that username exists or not? Like, have you ever wondered how that happens? Like, what's the data structure and algorithm that's involved behind that process? Well, today, let's find out. So let us understand how these big companies like Google, Amazon, Facebook, they keep track of their databases, and like how do they answer this question? Does this username exist? Because this is the sample question that we took. So let us assume that there's this application. So there's an application, there's a web page that is asking whether a username exists or not. So it is asking, does a user name exist? So this is a basic yes or no question. It can be either yes or no. It asks that from the server. So there's a server. Let's say this is an AWS web service, or a Django web service, and there is a database. This is the database which has all of the information about the user names. And traditionally what happens is that when the application asks if the username exists, the web server then creates a query in the database and checks if the username exists or not. And then the database returns that whether the thing exists and not. And after that, the value is returned to the application or the web page in this instance. So there's obviously a problem with it, because every database query is associated with a cost. And the more database queries we run, the more costlier it is going to be. Although it is a very simple application, but we need to keep in mind an optimal cost about this. So we need to reduce the number of queries that are going to the database. So how can we reduce it? One way to reduce it is storing the database, or storing the copy of a database in the memory of the server. So if the server, suppose, let's say it is an AWS server, so we'll store this entire database that we have here inside the memory, inside the random access memory of this server. So what will happen? If we store this in the server, there might be some times where this database is updated. Suppose there are new values added to the database, but that same new value is not added to the database stored in the memory. So these might go out of sync. And one of the main applications that helps you in storing a database on the physical memory is known as Redis. So let's say we are using Redis, but using Redis is not optimal, because if we have an in-memory database, it might go out of sync. It is okay for small values, but for large values, if suppose my server only has about 2 gigabytes of RAM and I have 100 gigabytes in my database, so this might go wrong. And that is where Bloom filters came in. So Bloom filter is essentially replacing it's essentially an in-memory representation. It's kind of an in-memory representation. So if I have 2 GB RAM, it's very tiny. It's usually very tiny. So I only have like a hash table, and it is extremely tiny. So let's assume that it's just 64 bits. So what happens is that in this table, we are given this table. So it's say like 0, 1, 2, 3, 4, 5, so on, 63 and 64. So let's say we have this table. So what will happen is that whenever let's also fill it up with sample values. So let's say I have a 1 here and a 1 at the 63. So let us say my application wants to know if Akshat exists in this database. So what essentially we need is hash function. So when the application sends a request that does Akshat exist, so we basically need a hash function to generate a value. So this hash function has generated a value. So let us assume that we have an application that is calling the server, that is calling the database, and then we have this in-memory representation of a Bloom filter. So what this Bloom filter is that suppose the application asks us to check if Akshat exists in the database. So what it will do is that it has a function, as it has a hashing function that will generate a value for Akshat. So suppose if when we type that hash Akshat, and also then we mod it by using the 64. So when we mod it 64, we know that the values can be anywhere from 1 to 63. So when the value is from between 1 to 63, let's say hash Akshat generates a value 4. So then we check the fourth value of this Bloom filter and we see that it is empty. If the Bloom filter value is empty, we can be 100% surely say that this username does not exist in the database. So let's say instead of Akshat, we have another value. Let's say we have Aryan. So when we hash Aryan, suppose I get a value 3. And when we mod it by 64 and we get a value of 3, when I check the Bloom filter, I see that the 3 value exists. So when we have a value, when we have the value in the Bloom filter filled, it does not necessarily mean that that value, that Rn exists in the database. But it means that we have to run a query to the database to check if Rn exists, because there might be some other string. Maybe there is another string named as Yash, that is modded by 64. It gives the value as 3. So there might be collision in this case, but we need to check the database to see if Rn exists or not. So I kind of save myself a few queries there. This can be improved. So obviously this is not perfect. If we have a very small Bloom filter and all of these values goes 1, then it's essentially the first case where we are directly just running each and every query to the database. So we have to keep in mind that this is not perfect, but in the same at the same time, the values the database queries can be saved. The many database queries can be saved if we implement it efficiently. So let us also let me show you another case where this can be used. Now let's say I have an empty Bloom filter. I want to fill in the values. So what we need to do is that suppose whenever a new user is created, suppose a user named as Akshat is created, which had the hash value when modded by 64 as 4. So then we go to the fourth. Let's say we have 63, 64. Maybe this is 63. This is 64. So when it has the mod value of 4, what we can do is that we go to the fourth index, we put it as 1. And similarly, when we have Aryan, who has a mod value of 3, we go to the third and we put it as 1. Suppose we have a value Yash. It is giving us a mod value of 3. So we go to the third index, we see that already 1 is filled. So this is where the collision happens. This is collision. So there are several ways of handling collisions. One of the main ways is that just leave it be. If the value is already filled, keep it filled, do nothing about it. The second way is to do something about it, obviously. And what we do is that instead of using just one hash function that gives a single value of 3, we use multiple hash functions. If we use suppose 2 hash functions or 3 hash functions, the same value Yash, different hash functions of course, the same value Yash will give us 3 unique values. Like if 3, 6 and 1. Suppose 3 hash function produce these values. So then what we need to do is that we need to fill all of these values as ones. So all of these values are filled as 1. So then every time we need to, search if Yash exists in the database, we need to search if all of these 3 values from the hash function are 1 in the Bloom filter. So then we can be sure, we can be like more sure that yeah, Yash does exist in the database. Keep in mind there are still chances that another string is there who might give same results for all of these hash functions, but the probability of that happening is very low, and as you keep on increasing the number of hash functions you have, it will keep decreasing. And that's what this technique is also improved by by cuckoo filter, which is essentially an upgrade of the Bloom filter. Thanks a lot for watching the video, and if you like it, please give it a like and don't forget to subscribe. Thank you.